July 7, 1944. 9:12 a.m. Yokosuka Naval Air Technical Arsenal south of Tokyo. The wind coming off Tokyo Bay carries the smell of fuel and hot metal across the airfield. Inside a narrow hangar lined with steel scaffolding and wooden work tables, a group of naval engineers stand beside something unlike any aircraft Japan has ever attempted to build. The machine rests on thin landing gear, its smooth fuselage painted in dull primer gray. Beneath its swept wings hang two long cylindrical nacelles. Inside those nacelles sit the heart of the gamble. Jet engines. Commander Kazuo Ono of the Imperial Japanese Navy Technical Department runs a gloved hand along the metal skin. The surface still feels warm from the morning's engine tests. Behind him, a mechanic wipes sweat from his face while tightening a fuel line connection. Across the hangar, Lieutenant Commander Kenichi Matsumura studies a blueprint spread across a wooden drafting table. The paper is crowded with measurements and handwritten notes. The aircraft is called the Nakajima Kikka. In Japanese, the name means orange blossom. But among the engineers gathered here, another phrase circulates quietly. Japan's answer to the jet age. Commander Ono looks toward the engines again. These will change everything, he says. The mechanic nods, though he does not fully understand the science behind them. What he understands is speed. The new engines promise something Japanese aircraft have never possessed in abundance: raw thrust. For years, the Imperial Japanese Navy has relied on aircraft like the Mitsubishi A-6M0, light, elegant, and deadly. In 1941, the Zero dominated the early months of the Pacific War. But by 1944, the skies have changed. American aircraft now appear faster, heavier, and better protected. The Grumman F-6F Hellcat tears through the sky at speeds the Zero cannot match. The Vought F-4 U Corsair climbs higher, and the newest threat has only begun to arrive: the Boeing B-29 Super Fortress. 4 engines, pressurized cabins, heavy defensive guns, flying higher than many Japanese fighters can reach. Commander Ono folds his arms. Jet engines promise to solve the problem in one brutal leap. No propeller, no piston engine, just pure exhaust thrust blasting backward to drive the aircraft forward. The idea came from Europe. Only months earlier, Japanese naval officers traveling by submarine had received technical reports about a revolutionary German aircraft, the Messerschmitt Me-262, the first operational jet fighter in the world. The reports described speeds exceeding 850 kilometers per hour, faster than anything in the Allied arsenal, faster than interception calculations assumed possible. In Berlin, German engineers claimed jet aircraft would restore control of the skies. Those reports traveled across oceans and battlefronts until they arrived here, at Yokosuka. Commander Ono taps the metal casing of the engine nacelle. "We are not behind," he insists. The words hang in the warm air of the hangar. Nearby, Lieutenant Commander Matsumura does not respond. He knows how fragile that claim really is, because this aircraft exists mostly on paper. The Kikka is still a prototype, and prototypes require time. Time for testing, time for manufacturing, time for training pilots to fly machines that behave very differently from propeller aircraft. Time Japan no longer possesses. Outside the hangar, the sky over Tokyo Bay remains clear. A few training aircraft circle lazily in the distance. For the moment, the war feels far away. But far above the Pacific Ocean, American reconnaissance aircraft are already mapping targets across the Japanese home islands. Factories, shipyards, airfields, fuel depots. The bombing campaign that will eventually cripple Japan's industrial capacity has already begun to form. Inside the hangar, the engineers focus on their machine. Lieutenant Commander Matsumura finally speaks. "If the Germans can do it," he says quietly, "we can do it faster." Commander Ono nods. Yes, the assumption feels reasonable. After all, Japan still has brilliant engineers. Nakajima Aircraft Company has already built some of the Empire's finest aircraft. And jet engines in theory are simpler than piston engines. Fewer moving parts. No complicated propeller systems. Just air, compression, combustion, and thrust. But theory is comfortable. Reality is mechanical. Reality requires metal alloys that can survive extreme heat. Reality requires fuel, and Japan's supply of aviation fuel is shrinking by the week. At the far end of the hangar, a young engineer named Lieutenant Hiroshi Sato studies a small turbine blade under a magnifying lamp. The metal has warped slightly after the last test. He turns the blade slowly between his fingers. Jet engines run hotter than anything the Japanese aviation industry has built before. Much hotter. The turbine blades must endure temperatures that push the limits of available materials. Germany solved part of this problem with special alloys. Japan has fewer of those resources. Lieutenant Sato writes a note beside the blueprint. Material fatigue at sustained temperature. He does not yet know how serious that problem may become, but for now, optimism dominates the room. Commander Ono walks around the nose of the aircraft and looks up at the cockpit canopy. Soon a pilot will sit there. Soon this aircraft will lift from the runway. Soon it will fly faster than any Japanese aircraft has ever flown. At least that is the expectation. Across the Pacific, American shipyards are launching aircraft carriers faster than Japan can track them. Factories in California and Texas produce thousands of aircraft every month. But those numbers remain abstract here inside the hangar. What matters is this machine, the Nakajima Kikka, a leap forward, a technological gamble. If it works, Japan might reclaim the skies. If it fails, the empire will face enemies whose aircraft grow faster every month. Commander Ono glances at his watch. "Run the engines again," he says. Mechanics move quickly toward the aircraft. Fuel pumps whine. Electrical cables snap into place. A moment later, the starter motor spins. Then the engine ignites. The jet engine does not roar like a propeller plane. Instead, it produces a rising metallic howl. The sound echoes across the hangar like a storm building inside a steel tunnel. Engineers watch the gauges carefully. Temperature, pressure, fuel flow. The numbers climb. For now, everything looks stable. Commander Ono smiles slightly. The gamble feels justified. But beyond the walls of this hangar, forces already in motion will soon begin to erase the time required for success. And no one here yet realizes how quickly that time is about to disappear. August 18th, 1944, 2:40 p.m. Nakajima Aircraft Company Engine Test Facility, Mitaka, Western Tokyo. The air trembles with the rising scream of a turbine. Inside the reinforced concrete test chamber, a prototype jet engine sits bolted to a steel frame. Pipes feed fuel into its combustion chamber, while gauges vibrate under the growing pressure of hot exhaust gases rushing through the turbine stages. The sound is sharp, metallic, and unnatural compared to the familiar rhythm of piston engines. Technicians stand behind thick glass panels, watching the needles climb. Lieutenant Hiroshi Sato grips a clipboard, his eyes fixed on the temperature gauge. 600 degrees, 700. The needle begins to shiver. Reduce fuel flow. Sato says quickly. A technician adjusts the control valve, but the engine does not calm. Instead, the howl grows harsher. Inside the turbine, casting metal is reaching a limit no one in this room fully understands. Then it happens. A sudden crack bursts from the test chamber. The howl stops instantly. Steam and smoke surge from the exhaust pipe. Inside the chamber, the turbine has shattered. Fragments of warped metal lie scattered around the mounting frame. The test engine has lasted only 9 minutes. Silence fills the observation room. Lieutenant Sato slowly lowers his clipboard. No one speaks for several seconds. Finally, a senior engineer from Nakajima clears his throat. "We expected some failures," he says carefully. But the tone in the room has changed. Jet engines are not simply faster versions of piston engines. They demand materials Japan does not easily produce. The turbines must survive temperatures that push the boundaries of metallurgy. Germany solved this by using high-temperature alloys containing chromium and nickel. Japan has very little of either. Even worse, the American submarine campaign has begun cutting Japan off from overseas resources. Cargo ships carrying ore from Southeast Asia are disappearing beneath the Pacific. Fuel shipments arrive irregularly. Industrial metals are rationed. And yet the Kikka project continues, because the threat from the sky is growing rapidly. Only weeks earlier, Japanese radar stations on Kyushu detected something unusual approaching from high altitude. Large aircraft, higher than most Japanese fighters could reach. The first Boeing B-29 Superfortresses had begun reconnaissance missions over the home islands. Their silver fuselages glided across the sky at over 30,000 feet. Japanese interceptors struggled to climb that high. Even when they succeeded, their engines gasped for oxygen in the thin air. The B-29s photographed factories, rail lines, airfields. They were mapping targets, preparing In Tokyo, Naval Command understands what this means. If the United States begins large-scale bombing from bases in China or the Pacific Islands, Japan's industry will become vulnerable in ways never seen before. Factories cannot easily move. Shipyards cannot hide. And jet aircraft promise a possible answer. Speed, altitude, interception. The Nakajima Kikka is designed specifically with those goals in mind. But the engineers know something the admirals prefer not to hear. The aircraft depends entirely on engines that barely work. Back in the test facility, the destroyed turbine is removed from the chamber. Lieutenant Sato examines the broken blades under a bright work lamp. Each piece has warped from extreme heat. The metal composition is too weak. "We need stronger alloys," he says quietly. The senior engineer sighs. There are none, not in sufficient quantities. Japan's steel industry is already struggling to produce armor, plate artillery barrels, and ship components. High-temperature jet turbine alloys sit far down the priority list. Yet the Navy insists the project move forward, because Germany appears to be succeeding. German reports continue arriving through diplomatic channels and rare submarine courier missions. The Me-262 is already flying combat missions in Europe. German pilots claim Allied fighters cannot catch it. Some reports describe jet aircraft attacking bomber formations at incredible speed. To Japanese Naval Command, these reports sound like proof. If Germany can deploy jet fighters while fighting the combined forces of Britain, the United States, and the Soviet Union, then Japan must follow the same path. Confidence remains strong in Tokyo. But the engineers working inside Nakajima factories see the problem from a different angle. They see shortages. Fuel is rationed even for testing. Some engine runs must be shortened simply to conserve aviation gasoline. Electric power interruptions delay manufacturing equipment. Replacement parts arrive late or not at all. And now the turbine blades are failing. Lieutenant Sato writes another note in his growing list of concerns. Turbine. Durability unacceptable under sustained thrust. He flips the page and adds another line. Fuel consumption extremely high. Jet engines burn far more fuel than piston engines, and Japan's fuel reserves are collapsing. American submarines are destroying tanker ships faster than Japan can build replacements. Every new aircraft design must now compete for the same shrinking supply of aviation fuel. Still, the Navy pushes forward, because the alternative is even worse. Without faster interceptors, the B-29 threat will grow uncontested. Across Tokyo, civil defense planners are already preparing for something unprecedented. High-altitude bombing, firestorms, industrial destruction. Inside the engineering offices, the Kikka blueprints continue to evolve. Engineers simplify the design wherever possible. The aircraft is intentionally small, lightweight, easy to manufacture with limited materials. The wings fold for storage. The landing gear uses simplified components. Some versions may even use rocket-assisted takeoff systems to reduce runway length. The concept is clever, but clever designs do not produce engines. Lieutenant Sato places the cracked turbine blades into a metal tray. He studies them one last time. These pieces of metal represent the fragile foundation of Japan's jet program. Without reliable turbines, the Kikka is nothing more than a promise. And promises cannot defend the sky. Outside the factory windows, the afternoon sky remains calm. But American planners thousands of kilometers away are already preparing the next phase of the war. In Washington and Hawaii, bomber commanders study maps of the Japanese home islands, fuel depots, aircraft factories, rail hubs. Every one of them sits within range of the B-29. And once the bombing begins in earnest, time will begin collapsing around Japan's fragile jet program. Inside the engineering office, Lieutenant Sato writes a final sentence in his notebook. Engine must survive 30 minutes continuous operation before operational deployment. So far, none have come close. November 24th, 1944, 12:03 p.m., Tokyo Bay Air Defense Sector. The sky above the capital looks calm at first. Thin winter clouds drift slowly over the city, while the waters of Tokyo Bay reflect a pale gray light. Fishing boats move quietly across the harbor. Freight trains clatter along the tracks leading toward the industrial districts. Then the radar station at Tateyama begins to register something strange. Inside the small operations room, a young radar operator named Petty Officer Ichiro Tanaka leans closer to the glowing screen. The signal pulses again and again. At first, he thinks it might be interference, but the pattern is too steady. Too organized, he calls across the room. Multiple contacts approaching from the southeast. Lieutenant Commander Masao Kurihara walks quickly toward the console. How many? Tanaka squints at the screen. At least 100. Kurihara feels his stomach tighten. 100 aircraft. No Japanese formation flies that large. He grabs the field telephone and speaks rapidly. Confirm with coastal stations. Within minutes, additional radar sites report the same thing. A massive formation approaching the capital. High altitude. Steady speed. The American bombing campaign has arrived. The first wave of Boeing B-29 Superfortresses appears over the distant horizon shortly afterward. They are so high that their silver shapes look like tiny glints of light against the winter sky. 30,000 feet, higher than most Japanese fighters can comfortably reach. Sirens begin wailing across Tokyo. Air raid warnings echo through the streets. Factories halt production as workers rush toward shelters. Inside the Tokyo Bay Air Defense Command Center, officers scramble to coordinate an interception. Major Saburo Sakai of the Imperial Japanese Navy Air Service listens to the radio reports coming in from radar stations. The voice on the receiver sounds tense. Enemy bombers approaching central Tokyo. Sakai knows the numbers. The Zero fighter, once the pride of the Navy, struggles badly at high altitude. Its lightweight construction becomes a weakness where oxygen is thin. Engines lose power. Climb rates collapse, but there is no choice. Japanese interceptors must try. Airfields around Tokyo begin launching everything available. Mitsubishi S6M0s, Nakajima Kikka 44, Tojos, a few experimental high-altitude fighters. Pilots push their aircraft upward with engines straining near maximum power. Inside one of those cockpits sits Lieutenant Hiroshi Takeda. His Ki-44 shudders as he climbs through 25,000 feet. The engine coughs slightly. Takeda adjusts the mixture control and pulls back on the throttle just enough to keep the engine from overheating. The bomber formation grows larger ahead. Rows of massive four-engine aircraft glide across the sky in disciplined formation. Takeda has never seen anything like it. The bombers appear calm, almost effortless. They fly straight and level their propellers, turning steadily in the thin air. From the ground, anti-aircraft guns begin firing. Black bursts of flak appear around the formation, but the bombers barely adjust their course. Inside the lead B-29, Colonel Emmett O'Donnell watches the Japanese flak bursts through the cockpit window. The American crews have trained for this moment. Months of preparation. Carefully planned routes. Precise bombing coordinates. The goal today is simple. Strike Japan's industrial heart. Destroy aircraft factories. Among those factories is the Musashino engine plant in western Tokyo. The same industrial network helping develop the jet engines for the Kikka project. Back in the interceptor cockpit, Lieutenant Takeda pushes his aircraft even higher. 27,000 feet. 28,000. The bomber formation is now directly ahead. He opens fire. His machine guns chatter briefly. But the distance is still too great. The B-29s keep moving. American defensive gunners respond quickly. Streams of tracer fire begin reaching toward the Japanese fighters. Takeda banks hard to avoid the incoming bullets. His aircraft vibrates violently. The bomber formation continues forward with relentless precision. Minutes later, the bomb bay doors open. Hundreds of bombs begin falling toward the city below. Factories, rail yards, industrial complexes. The explosions ripple across Tokyo like a chain of thunder. Smoke begins rising across the skyline. From the cockpit of his struggling interceptor, Takeda watches the bombs fall and feels a sinking realization. Japan's current fighters are simply too slow, too limited, too fragile to stop the high-altitude bombers effectively. When the raid ends and the American formation turns away toward the Pacific, Japanese commanders begin gathering damage reports. Several industrial sites are burning. Rail lines have been cut. Factory production will stop for days, perhaps weeks. Inside a military office in Tokyo, naval officers discuss the implications late into the night. Commander Kazuo Ono listens quietly as reports arrive. The bombers flew too high. Our fighters could not reach them in time. They escaped almost untouched. The room grows silent. Everyone understands the meaning. Japan's current aircraft cannot reliably intercept the B-29. Something faster is required. Something capable of climbing higher. Something with the speed to strike quickly before defensive gunners react. Ono finally speaks. The jet program must accelerate. Across the city, Lieutenant Hiroshi Sato stands inside the engine workshop, studying another partially assembled turbine. The news of the bombing raid has already reached the factory. Production teams work late into the night repairing equipment damaged by shockwaves. Sato runs his fingers along the turbine casing. The jet engine still struggles to survive even basic testing. Yet now the pressure to complete the project has multiplied. The sky has revealed a problem Japan cannot ignore. And somewhere inside the roar of that new American bomber fleet lies the beginning of a race Japan is already dangerously late to join. January 27th, 1945. 8:16 a.m. Naval Air Technical Arsenal, Yokosuka. The winter air is sharp along the runway. Technicians move quickly across the concrete apron, their breath visible in the cold morning light. Mechanics roll fuel drums toward a small aircraft parked near the edge of the airfield. The machine looks compact compared to most naval aircraft. Short wings, a narrow fuselage, two cylindrical nacelles hanging beneath the wings. The Nakajima Kikka prototype stands ready for ground testing. Commander Kazuo Ono watches from a few meters away, hands tucked inside his coat sleeves. Next to him stands Lieutenant Commander Kenichi Matsumura, studying the aircraft with a mix of pride and worry. Months of work have brought the project to this point. The engines are not perfect. The materials remain questionable, but the pressure from Naval Command has grown relentless. American bombing raids have increased steadily since November. Factories across the Tokyo region have already been struck multiple times. Reports from military intelligence describe the B-29 campaign expanding rapidly, and Japan still has no interceptor capable of reliably reaching them. Ono turns to Matsumura. The Germans already fly jets in combat. Matsumura nods slowly. That fact has become something of an obsession inside the Naval Aviation Command. German jet aircraft have been described in glowing reports sent through diplomatic channels. The Messerschmitt P-262 has reportedly shot down Allied bombers over Europe. Some German pilots claim it can appear suddenly attack at extreme speed and vanish before escorts can react. To Japanese commanders struggling against high-altitude American bombers, those reports sound like a solution waiting to be copied. But there is an uncomfortable detail often overlooked in those conversations. Germany began researching jet propulsion in the 1930s, years before the war reached its current intensity. Japan did not. The Kikka project began only after Germany had already tested multiple jet prototypes. Japan is attempting to compress years of development into months, and the engineers know it. A mechanic climbs onto a ladder beside the aircraft and signals toward the cockpit. Fuel lines secure. Another technician confirms the electrical connections. Lieutenant Hiroshi Sato stands near the engine nacelle with a notebook. He records the final inspection numbers. Fuel pressure stable. Starter motor ready. Combustion chamber temperature sensors active. He glances toward Commander Ono. We can attempt another run. Ono nods. Begin. A technician presses the ignition switch. The starter motor whines. Then the engine catches. A rising metallic scream fills the cold air. The sound is louder outside than it ever was inside the testing facility. People working in nearby buildings turn toward the runway. The jet engine continues building power. The aircraft vibrates slightly against its wheel chocks. Sato studies the gauges through a portable instrument panel. The temperature climbs again. 600 degrees, 700. The numbers approach the limit. Reduce throttle slightly. Sato calls. The mechanic adjusts the fuel control. The engine stabilizes for the moment, but no one relaxes. They have seen engines fail without warning. Inside the cockpit sits Lieutenant Commander Susumu Takaoka, one of the test pilots assigned to the project. His hands rest lightly on the control stick while he studies the instrument panel. He has flown many types of aircraft, but none with jet engines. Propeller aircraft respond immediately to throttle changes. Jet engines behave differently. They respond slowly, sometimes unpredictably. Takaoka understands that flying this machine will require new instincts. Outside the aircraft, Commander Ono watches the engine run and imagines something larger. Squadrons of jet fighters rising from Japanese airfields, streaking toward the incoming bomber formations, attacking before American escorts can react. The vision feels powerful, but it also hides a dangerous assumption, because jet aircraft alone do not solve the problems Japan now faces. The Kikka is designed as a light interceptor, small, fast, but lightly armed. Its fuel capacity is limited. Its range is short. and its engines still suffer from reliability problems. Even if the aircraft works perfectly, production numbers will remain small. Japan's factories are already struggling under bombing pressure. Steel shortages limit manufacturing capacity. Fuel shortages restrict pilot training. Each new aircraft design competes for resources with existing fighter production. None of those problems disappear simply because a jet engine exists. The engine continues running. 8 minutes. 9. Lieutenant Sato studies the temperature needle carefully. This time the engine survives longer than previous tests. The team exchanges cautious glances. Progress, however small, feels significant. But outside the airfield, the war is accelerating faster than the engineers realize. Across the Pacific, American forces have captured the island of Saipan. From that island, 29 bombers can reach Tokyo directly. The distance is short enough to support massive bombing campaigns. Entire fleets of bombers now operate from the Mariana Islands, and American production continues expanding. Factories in the United States are producing thousands of aircraft every month. New fighters, new bombers, new engines. Japan cannot match that scale. The Kikka project was never meant to compete with mass production. It was meant to provide a sudden technological advantage, a leap forward. But technological leaps require time, testing cycles, pilot training, operational experience. Each of those steps is now compressed under the weight of war. The engine finally powers down. Silence returns to the runway. Lieutenant Takoka opens the cockpit canopy and climbs out. He walks toward the engineering team. The vibration is manageable, he says. But throttle response is slow. Sato writes the note. Another limitation. Another detail that will require adjustment before flight testing can begin. Commander Ono folds his arms again. How soon can we attempt taxi trials? The engineers exchange uncertain looks. Weeks, perhaps longer, but no one wants to say that aloud. Because in Tokyo, Naval Command believes the jet fighter program is already close to operational readiness. And every bombing raid over the capital increases the urgency of that belief. Above them, the winter sky remains quiet. But somewhere beyond the horizon, American bombers are already preparing their next mission. March 9th, 1945. 11:47 p.m. Tokyo Eastern Industrial Districts. The sky above the capital glows an unnatural orange. From the rooftop of a government building near the Sumida River, Lieutenant Commander Kenichi Matsumura watches the horizon flicker with distant explosions. At first, the bombing sounds almost rhythmic, a dull thunder repeating across the city. But then the fires begin spreading. Hundreds of American B-29 bombers have arrived in waves. Unlike previous raids from high altitude tonight, the bombers fly low, very low. The aircraft pass over Tokyo at roughly 5,000 feet. Inside the lead bomber formations, American crews release thousands of incendiary bombs designed specifically for urban firestorms. Clusters of magnesium and napalm containers scatter across entire neighborhoods. Within minutes, fires begin merging together. The wooden homes of Tokyo ignite almost instantly. Strong winds push the flames from street to street, from building to building. Matsumura grips the cold metal railing of the rooftop as the firestorm spreads. Entire districts of the city begin disappearing beneath towering walls of flame. The air fills with black smoke. Even from kilometers away, the heat can be felt. Inside the Naval Command offices below, radio operators struggle to keep track of the chaos. Fire brigades report entire blocks burning out of control. Rail stations have been destroyed. Warehouses filled with aviation components are now engulfed in flames. And somewhere within the burning city sits the fragile industrial network supporting Japan's jet program. At the Nakajima engine facility in Musashino, Lieutenant Hiroshi Sato has already seen the firestorm approaching. The glow in the sky began hours earlier. By midnight, the sound of explosions begins reaching the factory. Workers rush outside. The horizon is a rolling wall of red and black smoke. Civil defense officers shout instructions. Evacuate non-essential personnel. Protect machine tools. Inside the engine workshop, Sato looks around the room. Blueprints cover every wall. Partially assembled turbines sit on wooden stands. Crates of unfinished components line the floor. Each piece represents weeks of careful work. And now all of it is suddenly vulnerable. The first incendiary bombs land less than a kilometer away. A moment later, the shock wave rattles the factory windows. The workers freeze. Then the alarms begin ringing. Fire teams prepare. But the scale of the attack quickly overwhelms any attempt at control. Hundreds of small fires begin appearing across the district. Wind pushes burning debris through the streets. Roofs collapse. Telephone lines go dead. By early morning, the firestorm consumes entire industrial blocks. The Musashino engine plant survives the night only partially. Several storage buildings have burned completely. A warehouse containing precision machining equipment is gone. Electrical generators have been damaged. When dawn arrives on a March the 10th, the full scale of the destruction becomes visible. More than a quarter of Tokyo lies in ruins. Tens of thousands of civilians have died. Factories that once produced aircraft engines, instruments, and components now stand as smoking skeletons. Lieutenant Sato walks slowly through the damaged workshop. The machines that survived are covered in soot and ash. One of the turbine test benches has collapsed after a nearby fire weakened the support structure. Sato runs his hand across a scorched metal casing. The jet program depended on precise manufacturing, precision machining, stable electrical power, reliable transportation for materials. The firestorm has disrupted all of it. Later that morning, Commander Kazuo Ono arrives at the damaged facility. He steps out of a military truck and surveys the scene. Engineers gather around him with grim expressions. How much production capacity remains, he asks. One of the factory supervisors answers quietly. Less than half. Replacement parts for the damaged machinery will take weeks to produce. Some specialized tools may be impossible to replace at all. And the bombing is not over. American bombers will return again and again. Ono nods slowly. But inside the Naval Command structure, something even more dangerous is happening. The jet program has now become a symbol, a technological miracle that many officers believe could reverse the war's momentum. Because admitting the truth would mean accepting something unthinkable. Japan's industrial capacity is collapsing. Fuel reserves are nearly exhausted. Pilot training programs have been shortened drastically due to fuel shortages. Even conventional fighter production struggles to keep pace with combat losses. And yet the Kikka project still demands resources. Steel, fuel, engine components, test pilots. Every resource diverted toward the jet program is one less available for aircraft already in combat. Inside a temporary command office, Matsumura reviews the latest damage reports. Rail lines serving several aircraft factories remain unusable. Electrical power interruptions continue across the region. Material shipments from other parts of Japan arrive late due to transportation disruptions. The jet program now faces a problem no engineering solution can fix. Time. Even if the Kikka flies successfully, mass production will require months. Months Japan may not have. Commander Ono reads the same reports later that evening. For the first time since the project began, doubt begins creeping into his thoughts. Not about the technology. The aircraft itself may still work. But about the timing. The war outside the laboratories and workshops is moving faster than the engineers can keep up with. The firestorm over Tokyo has revealed something unavoidable. Japan's industrial heart is now exposed, and every future bombing raid will strike deeper. April 7th, 1945. 1:22 p.m. Imperial Japanese Navy Headquarters, Tokyo. Inside a dim operations room filled with cigarette smoke and radio static, a naval officer lowers a headset slowly from his ears. No one asks the question immediately. The answer is already visible on his face. Admiral Suemu Toyoda, Commander-in-Chief of the Combined Fleet, stands at the center of the room beside a large operations map of the East China Sea. The officer speaks quietly. Battleship Yamato has been sunk. Silence spreads across the room. Yamato had been the largest battleship ever built. More than 70,000 tons. 9 massive 18-inch guns. For years it had symbolized the power of the Imperial Japanese Navy. Now it lies on the floor of the Pacific Ocean after being overwhelmed by American carrier aircraft. Hundreds of planes had attacked the ship before it could even approach its destination. The destruction had taken only hours. Admiral Toyoda stares at the map. The loss means more than the sinking of a ship. It means that American air power now dominates the Pacific completely. Japanese ships cannot move without being seen, and once seen they are destroyed. Across the islands south of Japan, American forces are advancing steadily. The battle for Okinawa has already begun. Hundreds of American ships surround the island. Thousands of aircraft fill the skies above the fleet. Inside Naval Command, the conversation turns quickly toward the future. Surface fleets can no longer challenge American carriers. Japan's remaining options grow smaller by the day. Submarines, defensive fighters, and experimental weapons. Among those experimental weapons is the Kikka jet project. Commander Kazuo Ono sits near the edge of the table listening to the discussion. The room contains officers from multiple divisions: naval aviation, engineering command, logistics. Everyone understands that time is collapsing. A staff officer spreads several reconnaissance photographs across the table. These are American bomber bases on Saipan and Tinian. Rows of B-29 bombers line the airfields. Hundreds of aircraft, each capable of reaching the Japanese home islands. Another officer places a separate report beside the photographs. Night bombing raids continue to expand. After the devastating firebombing of Tokyo in March, American bombers have begun attacking other cities: Osaka, Nagoya, Kobe. Entire industrial districts are burning. Factories that once supplied aircraft parts are disappearing one by one. Ono finally speaks. The Kikka interceptor can reach speeds no American propeller aircraft can match. Several officers nod. Speed still feels like the one remaining advantage technology might offer. But a logistics officer raises a difficult question. How many can we build? The room grows quiet again. The answer is painfully small. Even under ideal conditions, production might reach a few dozen aircraft within several months. But the conditions are no longer ideal. Factories are damaged. Transportation lines are unreliable. Fuel reserves are nearly exhausted. Another officer adds a new complication. The jet engines consume significantly more fuel than our current fighters. The statement hangs in the air. Fuel shortages already limit training flights for conventional aircraft. Jet engines burn even more. One of the younger officers suggests a solution that has begun appearing more frequently in strategic discussions. What if the aircraft are used only for special attacks? The phrase is spoken carefully. Special attack. Everyone in the room understands its meaning. Kamikaze missions. Aircraft used as guided bombs. No return flight required. The idea has already been used extensively in battles around the Philippines and Okinawa. But applying the concept to jet aircraft feels both desperate and strangely logical. A jet aircraft could approach American ships much faster than propeller-driven planes. Less time for anti-aircraft guns to react. Less time for fighter interception. The room divides quietly between those who see the idea as practical and those who view it as an admission of defeat. Commander Ono remains silent. The Kikka had originally been designed as a fighter interceptor, a machine to challenge enemy aircraft in the sky. Now some officers want to turn it into a one-way weapon. Admiral Toyota listens to the arguments without expression. Finally, he speaks. If the aircraft can strike American ships, it may change the situation. But even as the decision forms, another report arrives. American bombing raids are increasing again. Factories near Nagoya have suffered heavy damage. Several aircraft assembly lines are now idle. Production delays spread across the entire aviation industry. The jet program will not escape these disruptions. Later that evening, Commander Ono returns to Yokosuka to deliver the news. The engineers gather around a long workbench inside the hangar. Lieutenant Hiroshi Sato listens as Ono explains the new directive. The aircraft may be used for special attack missions. Sato looks at the partially completed Kikka airframe resting in the center of the hangar. The machine had been designed for speed and interception. Now it may become something else entirely. A weapon meant for a single flight. The engineers exchange uncertain glances. No one protests openly. By this point in the war, the concept of sacrifice has become deeply embedded in Japanese military culture. But inside the workshop, another problem grows increasingly obvious. Even if the aircraft are used for one-way missions, they still require working engines. And the engines still struggle to survive basic testing. Sato returns to his workstation and examines another turbine assembly. He rotates the shaft slowly. The metal surfaces are rough in places where precision machining tools were damaged during the Tokyo firebombing. Manufacturing tolerances are becoming less reliable. Even small imperfections can cause catastrophic failure in a jet engine. Outside the hangar, the evening sky grows dark. Somewhere far to the south, American carrier groups continue launching aircraft toward Okinawa. Thousands of machines, thousands of trained pilots. Japan's jet program now feels like a fragile experiment, trying to outrun a war already moving far too fast. May 12, 1945. 6:35. I am Nakajima Aircraft Company Test Field, Kisarazu, east of Tokyo Bay. A pale morning fog clings to the runway. The small airfield feels strangely quiet compared to the chaos spreading across the rest of Japan. Mechanics move slowly around a single aircraft positioned at the start of the concrete strip. For months, it had existed only as drawings and damaged components. Now, the machine finally stands complete. The Nakajima Kikka prototype. Its narrow fuselage glistens with a fresh coat of dull green paint. Two jet engines sit beneath the wings, their metal casings still showing faint marks from repeated adjustments and repairs. Lieutenant Commander Susumu Takaoka climbs into the cockpit. The canopy slides closed with a hollow click. Below him, technicians remove the wheel chocks. Commander Kazuo Ono watches from a few meters away, arms folded tightly. For nearly a year, the project has survived endless setbacks. Engine failures, material shortages, bombing raids. But today, the aircraft will attempt its first flight. Lieutenant Hiroshi Sato stands beside a portable instrument table connected to the aircraft through a cluster of cables. His notebook rests open beside the gauges. Fuel pressure stable. Starter system active. Temperature sensors ready. He raises his hand toward the pilot. Takaoka acknowledges with a brief nod. The starter motor engages. A high-pitched whine grows from the engine nacelles. Then the turbines ignite. The sound rises quickly into a metallic roar that echoes across the runway. Jet exhaust pushes hot air backward in shimmering waves. Unlike propeller aircraft, there is no spinning blade cutting through the air. Just the growing scream of compressed air and combustion. Takaoka gently advances the throttle. The aircraft begins rolling forward. At first, the acceleration feels slow. Jet engines take time to build thrust, but gradually the speed increases. 50 kilometers per hour. 70. The Kikka moves smoothly along the runway. Inside the cockpit, Takaoka keeps his hands steady on the controls. At 120 kilometers per hour, he pulls back gently. The aircraft lifts from the ground. For the first time, a Japanese jet aircraft climbs into the sky. Observers along the runway watch in silence. The machine rises smoothly above the airfield. Its engines leave faint trails of heat distortion behind them. Commander Ono allows himself a brief moment of relief. The concept works. The aircraft is real. For several minutes, the Kikka circles the airfield at low altitude. The controls respond well. The aircraft feels stable. The engines continue running without immediate failure. Lieutenant Sato studies the instrument readings carefully. Temperature within acceptable limits. Fuel flow steady. For the first time since the project began, genuine optimism spreads through the engineering team. After 15 minutes, Takaoka lines up for landing. The aircraft touches down smoothly. Applause breaks out among the mechanics. Some of them bow toward the aircraft as it rolls to a stop. Commander Ono approaches the cockpit as the canopy opens. Takaoka climbs down, removing his helmet. The handling is good, he says calmly, but acceleration is slower than expected. Sato writes the observation quickly. Another limitation, but the aircraft has flown. After months of doubt, the jet program has reached its first success. Yet even during the celebration, the original plan for the aircraft has already begun collapsing. Only days earlier, new bombing raids struck industrial areas near Nagoya. Factories producing aircraft components have suffered severe damage. Transportation lines across central Japan remain unreliable. Several critical parts needed for engine manufacturing are now delayed indefinitely. Even worse, aviation fuel supplies are reaching crisis levels. Training flights for conventional fighters have already been reduced drastically. Every liter of fuel must now be carefully allocated. Jet engines consume even more. Later that afternoon, the engineers gather in a small briefing room beside the hangar. Lieutenant Sato spreads several reports across the table. Engine production capacity remains extremely limited. The numbers are discouraging. Even with surviving factories operating continuously, the number of engines that can be produced each month remains tiny. Commander Ono listens quietly. How many operational aircraft could we deploy? Sato hesitates. Perhaps 20. The number feels painfully small. 20 aircraft cannot defend an entire nation. Another engineer raises a second problem. Pilot training. Jet aircraft require different flying techniques. Throttle response is slower. Landing speeds are higher. Without proper training, accidents will be common. But training requires fuel that no longer exists in large quantities. The room falls silent. The aircraft has proven it can fly. But everything surrounding the aircraft is collapsing. Industrial production, transportation, fuel supply, pilot training programs. The Kikka had originally been imagined as a squadron interceptor, a fast-response weapon capable of challenging American bombers. Now the reality looks very different. A handful of experimental aircraft, very few engines, almost no trained pilots. Outside the briefing room, mechanics continue inspecting the aircraft after its first flight. They measure engine wear carefully. One turbine blade already shows signs of heat stress. Sato studies the report. The engines survived this flight. But how many more can they endure? Beyond the airfield, American bombers continue striking cities across Japan. Each raid removes another piece of the industrial network required to build advanced aircraft. The jet program has succeeded technically, but strategically it now exists inside a collapsing system. Commander Ono steps outside and looks toward the western horizon. Somewhere beyond the mountains lies the growing shadow of American air power. The Kikka may be fast, but the war surrounding it is moving even faster. July 30th, 1945. 4:18. OM, Naval Air Base, Kisarazu, Tokyo Bay. A faint orange glow appears along the eastern horizon as dawn approaches. The airfield remains mostly quiet, though the silence feels tense rather than peaceful. Mechanics move carefully between hangars, with covered lanterns speaking in low voices. The distant hum of generators mixes with the occasional metallic clang of tools striking steel. Inside Hangar 3, the second Nakajima Kikka prototype rests beneath harsh electric lights. Its narrow fuselage looks almost fragile under the glare. The twin jet engines beneath the wings have been replaced with improved versions assembled from components scavenged across several damaged factories. Lieutenant Hiroshi Sato stands beside the aircraft studying a clipboard filled with notes. Each line of the page represents compromise, improvised materials, simplified manufacturing techniques, components produced by workshops that were never meant to build aircraft engines. The jet program has entered a new phase, not development, survival. Commander Kazuo Ono enters the hangar a moment later. His uniform looks more worn than it did a year earlier. Dark circles have formed beneath his eyes after months of sleepless nights and endless meetings. He studies the aircraft in silence. Is it ready? Sato hesitates slightly before answering. It can fly. The difference between those two statements hangs in the air. Ready and capable are no longer the same thing. The aircraft has flown before, but each flight risks exposing new weaknesses in engines that still operate dangerously close to their limits. Across Japan, the war situation continues deteriorating rapidly. American bombers now appear over major cities almost daily. The destruction spreads steadily outward from Tokyo toward every industrial center in the country. Entire aircraft factories have disappeared. Production lines that once manufactured fighter engines now exist only as charred steel frames. Transportation networks remain shattered. Rail lines frequently stop operating for hours after bombing raids. Convoys carrying aviation fuel often arrive half-empty due to shortages along the supply chain. Despite these problems, the Navy leadership continues demanding progress from the jet program, because it represents one of the last technological hopes still available. The Kikka is no longer expected to defend the skies. Instead, new orders have been issued. Special attack squadrons will eventually receive the aircraft. Each jet would carry a heavy explosive payload beneath its fuselage. The mission would be simple. Take off. Accelerate toward the approaching American fleet. Strike a carrier or transport ship before interception. The speed of the jet aircraft might allow it to slip through defensive fighter patrols. At least that is the theory. But the engineers understand something the strategists prefer not to discuss. Speed alone does not guarantee success. The American fleet surrounding Okinawa already deploys dense rings of radar detection fighter patrols and anti-aircraft guns. Even the fastest aircraft must still reach the target. Inside the hangar, mechanics finish attaching the final inspection panels on the engine nacelles. Sato climbs a ladder and examines the turbine housing closely. The metal surfaces look uneven. Some sections were machined using tools that lack the precision of the original factory equipment destroyed during bombing raids. He tightens one final bolt and climbs down. Commander Ono approaches him quietly. How long can the engines run? Sato answers honestly. We do not know. The turbines have survived several short test flights, but long-duration operation remains uncertain. Jet engines require stable manufacturing tolerances. Any slight imbalance can cause catastrophic failure once the turbine reaches full rotational speed, and the quality of materials has deteriorated dramatically. Earlier engines used the best alloys available. Now those materials are nearly impossible to obtain. Substitutes must be used. Each substitution introduces new risk. Outside the hangar, the sky begins turning pale blue as sunrise approaches. A test flight has been scheduled for early morning to avoid detection by American reconnaissance aircraft. Lieutenant Commander Susumu Takaoka arrives wearing his flight gear. He walks slowly around the aircraft, inspecting the wings and landing gear. Every pilot assigned to the Kikka program understands the danger. This machine is experimental, and the nation building it is collapsing under the pressure of war. But Takaoka also understands something else. The jet aircraft represents the final frontier of aviation technology. Even in this desperate moment, the chance to fly such a machine carries a strange sense of history. He climbs into the cockpit. The canopy closes. Ground crews signal readiness. The starter motor whines once more. The turbines ignite with the now familiar rising howl. The Kikka begins rolling forward along the runway. Acceleration builds slowly at first, then stronger. The aircraft lifts from the ground and climbs into the early morning sky. Observers on the airfield watch silently. The jet circles the bay for several minutes. Its speed remains impressive compared to conventional fighters, but the performance still falls short of the early expectations that once surrounded the project. Fuel consumption remains extremely high. Endurance is limited. Engine response continues lagging behind throttle commands. Inside the cockpit, Takaoka notices something troubling. A slight vibration begins building through the control stick. At first it feels minor, but gradually the shaking becomes stronger. He glances at the engine gauges, temperature rising. He reduces throttle slightly. The vibration decreases, but the message is clear. These engines cannot operate at maximum thrust for long. Takaoka turns back toward the airfield and prepares to land. When the aircraft touches down, the mechanics rush toward it immediately. Sato climbs onto the ladder and removes the inspection panel. The turbine blades inside one engine already show small cracks forming along their edges. Another flight has pushed the material closer to failure. Commander Ono studies the damaged turbine silently. The engineers have achieved something remarkable. Japan has built a jet aircraft during the final months of a losing war. But the machine has arrived at the worst possible moment. Factories cannot produce enough engines. Fuel cannot support training. Pilots cannot gain experience. The aircraft exists, but the system required to deploy it has already begun falling apart. August 6, 1945. 8:14 a.m., Naval Air Base, Kisarazu, Tokyo Bay. The morning sky above the airfield is unusually clear. A thin layer of mist hangs over the water beyond the runway, while mechanics prepare equipment inside the hangars. The jet aircraft program has entered a strange rhythm in recent weeks. Short test flights, endless repairs, meetings about production schedules that everyone knows cannot be achieved. Inside Hangar 3, Lieutenant Hiroshi Sato examines the damaged turbine blades removed after the previous flight. Under the bright lamp, the metal looks brittle. Tiny fractures run along the edges like hairline cracks in glass. Each flight pushes the engines closer to their limit. Sato writes another line in his notebook. Maximum sustained thrust, still unsafe. Across the hangar, Commander Kazuo Ono stands with Lieutenant Commander Kenichi Matsumura reviewing a new directive from Naval Headquarters. The paper is thin and creased from being passed between several offices. Production estimates for the Kikka program have been revised again. Even under the most optimistic conditions, only a handful of aircraft might be completed before the end of the year. But the war may not last that long. The American bombing campaign has grown relentless. Entire cities are now burning. Nagoya, Osaka, Kobe. Industrial districts that once supported aircraft manufacturing have vanished beneath smoke and rubble. Fuel reserves are nearly gone. Some training squadrons have stopped flying entirely. Despite these conditions, the Navy still hopes the jet aircraft might deliver one final surprise. A sudden strike against the American fleet gathering near Japan. The plan now under discussion involves launching several Kikka aircraft from improvised runways along the coast. Each aircraft would carry an explosive payload. Pilots would fly directly toward enemy ships. No return. Inside the hangar, the engineers listen to the proposal without enthusiasm. They understand the technical limitations too well. Even reaching the American fleet would be difficult. Radar detection would reveal the aircraft long before they approach the ships. Carrier-based fighters patrol constantly above the fleet. and the Kikka engines still struggle to maintain full power for extended periods. Lieutenant Sato closes his notebook. "We are building aircraft faster than we can test the engines," he says quietly. Commander Ono does not reply immediately, because another report has just arrived from Tokyo. At first, the message seems confused. Communication lines between several military offices have become unreliable due to repeated bombing damage. The report mentions an attack on the city of Hiroshima, but the details sound impossible. One bomber, one bomb, a city destroyed. Inside the operations office beside the hangar, radio operators attempt to confirm the information. Additional messages begin arriving. Observers in Western Japan describe an enormous explosion, a bright flash, a rising column of smoke towering high into the sky. Entire districts flattened instantly. Even experienced officers struggle to understand what they are hearing. Conventional bombing cannot destroy a city with a single aircraft. But the reports continue arriving. Hospitals overwhelmed. Military units unable to communicate. Survivors describing an explosion unlike anything ever seen. Commander Ono listens to the radio transmissions with growing unease. The jet program had always assumed time remained. Time to improve engines. Time to produce more aircraft. Time to train pilots. But this new weapon suggests something far more dangerous. The war itself may be approaching its end. Later that afternoon, the engineers gather again inside the hangar. The conversation is quieter than usual. The second Kikka prototype sits silently under the lights, its engines partially disassembled for inspection. Lieutenant Sato studies the aircraft with a strange mixture of pride and exhaustion. The machine represents months of relentless work under impossible conditions, against shortages, against bombing, against time. And yet the aircraft now feels strangely irrelevant. If the enemy possesses weapons capable of destroying entire cities in a single strike, then the future of air combat may already be changing again. 2 days later, another message arrives. August 9th, a second city destroyed, Nagasaki. The reports become impossible to ignore. The scale of destruction is beyond anything Japan has experienced during the war. Inside naval headquarters in Tokyo, senior commanders begin discussing the possibility of surrender. For many officers, the idea remains unthinkable. But the situation grows more desperate each hour. The Soviet Union has also declared war and begun invading Japanese positions in Manchuria. Multiple fronts are collapsing simultaneously. Commander Ono stands alone beside the Kikka aircraft late that evening. The hangar is quiet now. Most of the engineers have gone home. The jet fighter program had once represented a bold technological leap, a chance to challenge the enemy with speed and innovation. But the aircraft has arrived at the end of a war that no longer allows time for such experiments. Outside the hangar, the distant sound of another air raid siren echoes across the bay. Even now, American bombers continue flying toward Japanese cities. The sky that the Kikka was meant to defend is already dominated by thousands of enemy aircraft. Commander Ono rests his hand against the cold metal of the jet engine nacelle. For the first time since the project began, the realization feels unavoidable. The technology has arrived, but the war has already moved beyond it. August 15th, 1945. 11:58 a.m. Naval Air Base, Kisarazu, Tokyo Bay. The entire airfield stands still. Mechanics who normally spend the morning repairing engines now gather quietly outside the hangars. Pilots stand beside trucks and fuel drums. Engineers leave their drafting tables and walk slowly toward a small radio placed on a wooden crate near the center of the airfield. The broadcast is about to begin. For the first time in history, the voice of the Emperor will speak directly to the Japanese people. Inside Hangar 3, Lieutenant Hiroshi Sato stands beside the Kikka prototype. The aircraft remains partially disassembled after its most recent inspection. One engine rests on a metal stand nearby, its turbine blades removed for examination. Commander Kazuo Ono walks in from the bright sunlight outside and stops near the nose of the aircraft. Neither man speaks. From outside the hangar, the faint crackle of radio static drifts inward. Then the voice begins. Calm, measured, formal. Many of the men listening struggle to understand the archaic phrasing of the imperial broadcast. The language is ceremonial and indirect, but the meaning slowly becomes clear. Japan will accept the terms of surrender. The war is over. Outside the hangar, several mechanics bow their heads. Others remain perfectly still. No one cheers. No one protests. The moment feels strangely quiet after years of chaos. Inside Hangar 3. Sato looks down at the turbine blades lying on the workbench. The metal pieces seem almost symbolic now. So much effort had gone into trying to make them stronger. Heat-resistant alloys, improvised machining techniques, countless test runs that ended with shattered components and warped metal. All of it aimed at producing a machine that might defend the nation's skies. Commander Ono slowly walks around the aircraft. The Kikka stands complete except for the removed engine. Its sleek shape still looks futuristic compared to the propeller aircraft scattered across the airfield. If the war had lasted another year, perhaps dozens might have flown. If the factories had remained intact, perhaps the engines would have improved. If the fuel supply had survived, perhaps pilots could have trained properly. But the war did not wait. The jet program had entered existence during the final moments of a collapsing empire. Outside the hangar, pilots begin removing insignia from several aircraft. Orders have already arrived from Tokyo. All military operations are to cease immediately. Aircraft will remain grounded. Weapons secured. The once busy airfield now moves slowly through a strange routine of surrender. Lieutenant Commander Susumu Takaoka arrives at the hangar entrance and removes his flight cap. He looks toward the Kikka aircraft for several seconds before speaking. So that was the end. Commander Ono nods quietly. Neither man says anything else. The jet aircraft had flown. The engineers had proven that Japan could build a machine powered by turbines rather than propellers. The technology had arrived, but it had arrived too late to matter. Across the Pacific, American forces continue receiving reports confirming the surrender. Carrier fleets remain on alert, but combat operations stop. Bomber groups preparing for additional raids stand down. The massive industrial machine that had overwhelmed Japan begins slowing for the first time in years. Back at Kisarazu, Sato carefully places the turbine blades into a small wooden crate. There is no longer any reason to repair them. The aircraft will not fly again. Later that afternoon, several American reconnaissance aircraft appear high above Tokyo Bay. They circle the region quietly, observing airfields and naval bases below. No Japanese fighters rise to intercept them. On the runway outside the hangar, rows of aircraft sit motionless. Zeros, training planes, and at the far end of the field, the experimental jet prototype. A few weeks later, American inspection teams will arrive to examine these machines. Engineers from the United States will study the design of the Kikka carefully. They will photograph the engines, measure the turbine components, review the blueprints scattered across drafting tables. For them, the aircraft represents a technological curiosity, a glimpse of what Japan had attempted during the final months of the war. But for the engineers who built it, the machine carries a different meaning. Commander Ono stands beside the aircraft one last time as the sun begins lowering toward the western horizon. The hangar grows dim. Long shadows stretch across the concrete floor. He places his hand against the smooth metal of the engine nacelle. The metal feels cold. Months earlier, the engine inside had screamed with the power of compressed air and burning fuel. Now it sits silent. Beyond the airfield, the calm waters of Tokyo Bay reflect the fading sunlight. Ships move slowly along the distant horizon. None of them carry the urgency of war. Lieutenant Sato closes the crate containing the turbine blades and sets it beneath the workbench. Around him, the hangar grows quiet as workers leave for the evening. The jet aircraft remains where it stands, an invention born during desperation, a machine built to race into a sky that the war had already decided.